Good day everyone. Welcome to our review for the subject Abstract Algebra. I am EMorante and I will be your review master for this subject. So the contents of this review are the following topics. Number 1, we have matrices. So here in the matrices, we'll be dealing with the different types of matrices such as rows matrix, columns matrix, rectangular matrix, square matrix, diagonal matrix, scalar, identity, triangular, null or zero matrix, and lastly is the transpose of a matrix. And secondly, we'll be dealing also with the operations on matrices such as how to add and subtract two different matrices. So what are the rules in adding and subtracting matrices? We also have multiplication on matrices. Here in the multiplication of matrices, there are two categories. So we will find out later on as we go along with the discussion what are those categories in multiplication of matrices. And lastly is the determinants. And here in the determinants, we'll be focusing on finding determinants of a 2 by 2 and a 3 by 3 matrix. So matrices. Let us define first what is a matrix. So matrices or matrix are rectangular array of numbers, symbols or expressions arranged in rows and columns. And the elements of matrices can be a real number, complex, or a function. It is read as m by n, where m pertains to the number of rows while n refers to the number of columns. So m by n here refers to the dimension of the matrix. Say for instance, this one is an example of a matrix, and everything that you see inside this bracket, this brace, is called an element. So all of the element, it can be a real number, it can be a complex number, or also a function. And if we locate an element in a matrix using rows and columns. Let's say for example, the element located here is in the second row, uh, and second row column 2, or row 2 column 2. Also here, the element located here is in the second row first column, and so on and so forth. So what are the different types of matrices? First, we have the rows matrix. So the rows matrix are types of matrices wherein it contains only one row. Say for instance, 1 by 3 matrix, this one. This is a 1 by 3 matrix because it contains one row and 3 columns. So the number of columns doesn't matter as long as it contains only one row, then the type of matrix is a rows matrix. Next, we have columns matrix. Now, opposite to the rows matrix, a column matrix contains only one column. For instance, a 3 by 1 matrix. Okay, this one. This is a 3 by 1 matrix because it contains 3 rows and only one column. And the number of rows doesn't matter as long as it contains only one column, then that matrix is a columns matrix. Next, we have a rectangular matrix. So a rectangular matrix is a type of matrix wherein it contains 2 or more rows with 2 or more columns. For example, a 2 by 3 matrix such as this one, 2 by 3 matrix containing elements 1, 2, 3, 4, 5, and 6. So we also have other matrices wherein it belongs to the rectangular matrix, such as 3 by 2, 3 by 5, 4 by 6, 4 by 7, and so on and so forth. Next, we have the square matrix. So a square matrix is identified easily because the number of rows and the number of columns are just equal. For example, a 3 by 3 matrix such as this one, there are 3 rows and there are also 3 columns. So we can also have 4 by 4, 5 by 5, 6 by 6. As long as the number of rows and the number of columns are equal, then the matrix is a square matrix. Next, we have diagonal matrix. So a diagonal matrix is a type of matrix wherein all the elements on the non-diagonal or the non-diagonal elements are 0. Say for instance, this one, a 3 by 3 matrix wherein the only elements other than 0 are the one in the diagonals or the diagonal elements. So as you can observe, all of the elements other than the elements in the diagonal are all 0. Next, we have a scalar matrix. So a scalar matrix, similar to a diagonal matrix, here it also pertains not to the diagonal. No. In a scalar matrix, the diagonal elements are the same. Sorry. So the diagonal elements are the same. Say for instance, we have here two matrix A and matrix B. We have here the elements in matrix A contains 3 0 0 3, and for matrix B 3 0 0 0 3 0 0 0 3. And as you can observe, um, the elements on the diagonal are the same. They are both 3. Also here on matrix B. Okay, so question. The, for scalar matrix, does it need that the elements on the non-diagonal are all zero? Okay. Because here in the example, the elements on the non-diagonal are all 0. The answer is no. Um, the the elements here can be other numbers as long as the elements on this diagonal are equal or the same. Next, we have the identity matrix. So the identity matrix is a type of matrix where all of its diagonal elements are equal to 1. Okay. On the scalar matrix, the elements are the same. And here on the identity matrix is a bit different because the elements on the diagonal should be equal to 1 only. No other numbers, just 1. For instance, we have this matrix A again and matrix B. Matrix A containing elements 1 0 0 1 and matrix B containing elements 1 0 0 and 0 1 0 0 0 1. And as you can observe, the elements here on the diagonal are 1. They are all equal to 1. Also in the matrix B. So next we have the null or zero matrix. Now, based on the name itself, null or zero matrix, we can get an idea already that this matrix contains elements of 0. All of the elements inside this matrix, this type of matrix, are 0. Next, we have the triangular matrix. So the triangular matrix is divided into two. First is the lower triangular and the second one is the upper triangular matrix. So how do we identify if it is a lower triangular or if it is an upper triangular matrix? So for lower triangular matrix, you just see the elements below these diagonal elements. No. If the elements below this diagonal are all 0, then that is a lower triangular matrix. For example, this one, matrix A. Here, the elements below this diagonal are all 0. And for upper triangular, it's just the opposite. The elements above this diagonal are the one which is 0. Okay, next we have the transpose of a matrix. So for a transpose of a matrix, the question here is how do we obtain a transpose of a matrix? So given a certain matrix, um, in order to obtain for its transpose, we just interchange the rows into columns. So the rows here on the given matrix will become the columns on the transpose of that particular matrix. So as you can observe, we have here elements on the first row 1, 2, 3. So it becomes the elements on the first column in the transpose. Also 4, 5, 6, which are the second row elements, becomes the elements on the second column on the transpose. So for transpose, you just interchange the rows into columns. The first row will become the first column on the transpose, and the second row of the given matrix will become the second column on the transpose of the particular matrix. So next we move on to the operations on matrices. So here we will review on how to add and subtract a matrix. Now there are rules in adding and subtracting two different matrices that you need to consider. First, we can only add or subtract two different matrices if they have the same dimension. So take note of this one. Um, i- you cannot add or subtract two different matrices if they have different dimensions. Say for instance, a 2 by 3 matrix cannot be added or subtracted to a 3 by 2 matrix. So this should be 2 by 3 and added to a 2 by 3 matrix. The dimensions should be similar or should be the same. And next is, if they differ with the numbers of rows and columns, addition cannot take effect. So that is the idea that I have mentioned earlier, that you cannot add here if they have different dimension. So in adding and subtracting the matrices, so you just get the sum or the difference of the corresponding elements. So when we say corresponding elements on a matrix, those are the elements wherein they are on the same location. Say for instance, the element on the first matrix is on the um, first row, first column, then its corresponding elements is also the first row, first column on the second matrix. Say for instance, this one, we have here, we are asked to find for the sum of matrix A and B. And as you can observe, A and B have the same dimension. They are both 2 by 3 matrix because it contains 2 rows and 3 columns. So you can add A and B since they have the same dimension. They are both 2 by 3 matrix. And the corresponding elements here are 1 and 7 because 1 is in the first row, first column of matrix A, and 7 is also in the first row, first column of matrix B. So similar with the others, we have 2, 8, 3 and 9, 10 and 4, 11 and 5, and 12 and 6. So to get the sum of these two matrices, again you just get the sum of the corresponding elements. We have 1 plus 7, that is equal to 8, 2 plus 8, which is equal to 10, 3 plus 9 is 12, 10 plus 4 is equal to 14, and 11 plus 5 is 16, 12 plus 6 is equal to 18. So for subtraction, similarly to addition of matrices, they should be of the same dimension again, and you just get the difference of the corresponding elements. Here, we get the difference of 1 and 7, 2 minus 8, 3 minus 9, 10 minus 4, 11 minus 5, 12 minus 6. And the resulting matrix or the difference of matrix A and B is a matrix containing elements negative 6, negative 6, negative 6, 6, 6, 6. So next we have matrix multiplication, and here on matrix multiplication, this is divided into two categories. First, we have the scalar multiplication. So what do we mean by scalar multiplication? For example, we have here a matrix containing elements 1, 2, 3, 4, 5, and 6. So as you can observe, we have here a number outside the matrix. So this one is what you call the scalar. So this number 5 here outside the matrix is what you call the scalar. Now in order to find for the product of this scalar and this matrix, you just distribute this scalar to each of the element inside the matrix. So this becomes 1 times 5, 2 times 5, 3 times 5, 4 times 5, 5 times 5, and 6 times 5. And therefore, the resulting matrix contains elements 5, 10, 15, 20, 25, and 30. So, for scalar multiplication, any number here or any function, because it could be a function or an expression, you just distribute that one inside um, to all the elements inside the matrix. Next, we have if we are to multiply two different matrices. Take note that here on matrix multiplication, this is only done for matrix multiplication can only be done for square matrices. So you cannot multiply here uh, 2 by 3 and then 3 by 2 because they will differ on the number of rows and the number of columns, because the rule here for multiplication of two different matrices, the rows is being multiplied, and the elements in the rows and the first matrix is being multiplied to the columns, to the elements in the columns of the other matrix. So just take note that this should be a square matrix, a 3 by 3, 4 by 4, and 5 by 5. So 3 by 3 multiplied by a 3 by 3 matrix, that's it. So here, based on its definition, unlike scalar multiplication with only a single number to be multiplied in a matrix, in matrix multiplication, both matrices are to be applied. So here, for instance, given here 2 by 2 matrix, matrix A and B. So for A, it contains elements 0, 1, negative 1, 2. And for matrix B, we have here containing elements 6, 2, 5, negative 3. So how do we get the product of these two matrix? First is, what you need to do is, here, we have for matrix A, the elements on the first row are 0 and 1. And in order to get for the element on the first row, first column of the product, you multiply these rows to the elements on the first column of the second matrix. But here in multiplication, you multiply the elements that the corresponding elements. So we have here 0. This should be multiplied by 6 because this one is on the first row, first column, and 6 is also in the first row, first column. So next, so this is 0 times 6. You add that one, the product, you add that one to the product of this 1 and 2. So 1 times 2, that is equal to 2. Similarly to the others, for elements here on the first row, second column, since this is the first row of the first matrix, and this one is the second column of the second matrix, matrix B, we multiply 0 times 5. So 0 times 5 plus 1 times negative 3. And here, to find for the element here on the second row, first column, we have negative 1 because we are now on the second row. So first column. Okay, so negative 1 times 6 plus 2 times 2. And lastly, for this For this element here on the second row, second column, we have second row and then second column of the matrix B. Negative 1 times 5 plus 2 times negative 3. And then what you need to do is to simplify. We have 0 plus 6 plus 1 times 2. This becomes 0. And 0 plus 2 is, uh, this is typo error. This should be positive 2. We also have here 0 times 5 is 0. And 1 times negative 3 is negative 3. Next we have negative 1 times 6 is negative 6. Plus 2 times 2 is 4. So negative 6 plus 4 is negative 2. And negative 1 times 5 is negative 5. Plus 2 times negative 3 is negative 6. And negative 5 minus 6 is negative 11. So the resulting matrix contains elements 2, negative 3, negative 2, and negative 11. Next, we have determinants. So for determinants, here we will be finding for the determinants of a 2 by 2 and a 3 by 3 matrix. But first, let us review what are determinants. So determinants are likely matrices. However, if matrices are done with braces, determinants are done with absolute values. So take note of that. That is why here on the determinants, the elements are enclosed in an absolute value sign. So in finding for the determinants, we will simply apply multiplication diagonally, then perform subtraction. So you multiply the elements on the diagonals and you subtract or you get the difference of the products. So for instance, let us first discuss how to find for the determinants of a 2 by 2 matrix. So given these determinants, as you can observe, this one is enclosed within absolute value sign, not a brace. So this is what being mentioned here, the difference between matrix and then the determinants. So in order to find for the determinants of this given here, we have first get the product of this diagonal 4 and 5, also 0 and negative 7. So after getting the product, you get the difference. This becomes 4 times 5 minus 0 times negative 7, and 4 times 5 is 20, and 0 times negative 7 is 0. So 20 minus 0 is still 0. Therefore, the determinant is equal to 20. So next we have in finding for the determinants of a 3 by 3 matrix. So how do we find? Because the way of finding the determinants of a 3 by 3 matrix is a bit different on finding the determinants of 2 by 2 matrix. So here the way or the rule in finding for the determinants we have here. First, we need to extend the determinants grid by simply rewriting the first two columns of numbers. So again, multiply diagonally both downward and upward, then proceed to subtraction. So what do you mean by that? For example, here, this one is our original, the one being shown to you with the previous slide. This one is the original matrix. We have elements 1, 0, 3, 0, negative 2, 5, 4, 8, negative 1. So first, it is said here that you need to extend first the determinants grid by rewriting the first two columns. So this one are the first two columns, and you rewrite that one here, making this 3 by 3 matrix a 3 by 5 matrix. So, naging 3 by 5 na siya because you have rewrite the first two columns. And after doing that, you need to get for the product of these diagonals, you have negative 1, 1 negative 2, negative 1. So, these are the elements in the diagonal downward. Next, we have 0 times 5 times 4, and we have 3 times 0 times 8. And also, you get the product of these diagonals, this upward diagonal, the element in the upward diagonal. We have 4 negative 2 times 3, we have 8 times 5 times 1. Also, we have negative 1 times 0 times 0. So, after getting those products, okay, so after getting those product, whatever the product that you obtain here, you just get the sum, and then you subtract, no, the whatever the product that you obtain here, you subtract that one to the sum of the products here. So this becomes okay. Okay, so this becomes 1 times negative 2 times negative 1 plus 0 times 5 times 4 plus 3 times 0 times 8 minus 4 times negative 2 times 3 minus 8 times 5 times 1 minus negative 1 times 0 times 0. So next step is to simplify. We have here 1 times negative 2 times negative 1 is positive 2. And then here 0 times 5 times 4 is 0. So 3 times 0 times 8 is also 0. Negative 4 times negative 2 times 3 is 24. We have negative 8 times 5 times 1 is negative 40. And also here, negative 1 times 0 times 0, that becomes 0. So therefore, we have here 2 plus 24, that is 26. And 26 minus 40 is equal to 14. So that is how you find for the determinants of a 3 by 3 matrix. Next, we have here, okay, so let us try these sample problems and try to find out if we have learned something based on the discussion. So we have here sample problems. In answering, you can pause this video and you try to um, answer on your own. So for number 1, we have here given two matrices, matrix A and B. We are asked to find for the A minus 2B. So A minus 2B. This means to say we have here matrix A subtracted by this scalar 2 which is multiplied to matrix B. We have here given for letter A, that one. We have letter B, C, and letter D. So for letter A, it contains elements 2, negative 12, negative 22, negative 4, negative 6, 4. And for matrix, for letter B, we have negative 4, negative 6, 4, negative 3, 2, 9. For letter C, we have negative 1, negative 10, negative 13, 4, negative 1, 5. And for letter D, we have negative 1, negative 10, negative 13, 0, negative 7, and 1. So go ahead and try to solve this problem. Okay, so in order to find for A minus 2B, first we have here, you multiply negative 2 to matrix B. So this scalar negative 2 to matrix B, and after getting the result, you add that one to matrix A. So again, in multiplying the scalar, we just distribute the scalar to each of the elements inside this matrix. So we have negative 2 multiplied by negative 1. That becomes positive 2. We have negative 2 multiplied by 6 is 12. We have negative 2 This is negative 12. So negative 2 multiplied by 11 is negative 22. We have negative 2 multiplied by 2 is negative 4. And negative 2 times 3 is negative 6. We also have negative 2 times 2 is negative 4. Okay, so next is, since we already have the result of multiplying the scalar negative 2 to the elements, then we add this one to matrix B. So this becomes negative 3 plus 2, that is equal to negative 1. We have negative 1 and 2 plus negative 12 is negative 10. Next we have 9 plus negative 22, that is negative 13. We have 4 plus negative 4 is 0. Negative 1 plus negative 6 is negative 7. We have 5 plus negative 4 is 1. And therefore, the resulting matrix now contains elements negative 1, negative 10, negative 13, 0, negative 7, 1. And therefore, the answer is letter D. So number 2. So for number 2, you get the product of these two matrices. We have here the first matrix containing elements 6, negative 2, 8, 4. We have for the second matrix containing elements 2, 3, 11, and 2. So choices, we have for letter A, negative 10, 14, 60, 32. We have B, negative 2, 4, 2, 11. We have C, negative 6, 14, 8, 32. Letter D, 3, 2, 10, and 60. So again, go ahead and pause this video and try to find for the product of these two matrices. So again, in getting the product, so for the first element, we have 6 multiplied by 2. This is our first row and first column. So first row, first column, that will be on the first row, first column of the resulting product. So 6 times 2, that is 12. And then negative 2 times 11 is negative 22. So this becomes negative 22. Next, we have here for the second row, first column. This is the second row, and again, this is the first column. We have 8 times 2, that is 16. And then 4 times 11 is 44. Next, we have for the element here on the first row, second column, we have 6 times 3 is 18. And negative 2 times 2 is negative 4. And lastly, for this element here on the second row, second column, we have second row and second column. This becomes 8 times 3, that is 24. And then 4 times 2 is 8. So you just simplify. 12 minus 22, that is negative 10. 16 plus 44, we have equal to 60. 18 minus 4 is 14. And 24 plus 8 is equal to 32. Okay, Therefore, the resulting matrix now, the product of matrix, this matrix, and the other one is negative 10, 14, 60, and 30. So the answer for that is letter A. Number 3. So for number 3, we are asked to find for the determinants um, of this matrix containing elements 3, 10, 9, 7, 0, 1, 8, 7, and 2. So we have here letter A 90, letter B 180, letter C 270, and letter D 360. So again, just pause this video and try to find for the answer of the determinant. So here, again, in finding for the determinants of a 3 by 3 matrix, you just extend the grid by rewriting the elements in the first two columns. So we rewrite 3, 7, 8, 10, 0, and 7. And again, you get here the product. So 3 times 0 times 2, that is equal to 0. And then 10 times 1 times 8, that is equal to 80. So next we have here 9 times 7 times 7. So 9 times 7, that is equal to 63. And 63 times 7, that is equal to 441. Next we have here 8 times 0 times 9, that is equal to 0. And 7 times 1 times 3, that is equal to 21. And we have here 2 times 7 times 10. So 2 times 7 is 14, and 14 times 10, that is equal to 140. Okay, and here we just get the sum of 80 and 441. So 80 plus 441, this becomes 521. And minus 21, negative 21 minus 140, this is equal to 100, negative 161. And lastly, 521 minus 161 is equal to 360. So therefore, the determinants is equal to letter D, 360. Number 4. So here, what is the value of x that will satisfy, okay, given this matrix containing elements x minus 3x plus 7, 5x plus 5, which is equal to negative 50. For letter A, we have 4, letter B, 1, letter C, 3, letter D is 2. Okay, so again, pause this video and answer. So the solution here, first, as you can observe, this matrix is enclosed by a absolute value sign, meaning to say the resulting here, negative 50 is the determinant. So in finding for the determinant, and you can formulate here an equation. The rule is you get the product of the diagonals, and after getting the product is you get the difference of those products. So therefore we have here x minus 3 times 5 and minus 5x times x plus 7. Okay, so this one is equal now to negative 50. Okay, so next is we just simplify this one. 5 times x, we have here 5x, and 5 times negative 3 is negative 15. We have negative 5x times x, that is equal to negative 5x squared, and then negative 5x times 7 is negative 35x. So this is equal to negative 50. Okay, next. So we combine the terms having our similar terms. We have 5x. We can combine this one to negative 35x. And negative 15, let us combine this one to negative 50. By transposing, so transpose na lang yung negative 15 the other side of the equation. And first, we will write negative 5x squared. So here, 5x minus 35x, that is equal to negative 30x. And this is equal to, so this one negative 15 becomes positive 15. So positive 15 minus 50, that is equal to negative 35. Okay. Next is, since the coefficient here of 5 and of x squared and x and the constant here are all divisible by negative 5, therefore we can just divide this whole equation by negative 5, and negative 5x squared divided by negative 5 is x squared, and negative 30x divided by negative 5, that is positive 6x. So this is equal to negative 35 divided by negative 5, that is equal to 7. Okay, next we have here, we just transfer this positive 7 to the left side of the equation. This becomes x squared plus 6x minus 7 is equal to 0. Okay, so we have here a quadratic equation, x squared plus 6x minus 7, and in order to find for the value of x, we just factor out. Okay, so we have here x and another x, and here you'll be looking for factors of negative 7, wherein if you add that one, that will result to positive 6. So the factors are positive 7 and negative 1, because 7 times negative 1, 7 multiplied by negative 1, that is equal to negative 7, and 7 plus negative 1 is equal to 6. There. And therefore this becomes x. Okay. This becomes x plus 7 and x minus 1. And our values for x are negative 7 and positive 1. So based on the choices here, since we don't have any negative 7, therefore we'll be choosing positive 1, and the answer is letter B. So you can also check this one by substituting this value, this positive one, here, and you get the determinant. So if that results to negative 50, then therefore your answer is also correct. We have number 5. Which of the following is a lower triangular matrix? So we have letter A, B, C, D. Again, the idea here for lower triangular matrix is the numbers or the elements below the diagonal are all 0. So we just find here on the choices what are the elements or what are the matrices wherein it contains elements below the diagonal 0. So here, this is automatically wrong because the elements are not 0. So this is wrong. For letter B, this one is the opposite. This is the upper triangular matrix because um, the 0 elements are the one which are on the um, above the diagonal elements. So here, letter C is a triangular matrix. So this one is the triangular matrix because the elements below these diagonal elements are all 0. But here, for letter D, although the elements are 0 below this diagonal, so this one is most suited to a scalar matrix. So this one is an example of scalar matrix. And letter C is the best answer for this question. Number 6, which of the following is a scalar matrix? So again, we have here letter A, that one for letter B, letter C, and letter D. Okay, so let us try to eliminate. We have letter C, this is a null or 0 matrix. For letter C, again, this is the upper triangular matrix. We have for letter B, okay. Since in the diagonal elements, we have here 771, this one is not a scalar matrix. So letter A is the correct answer because the elements on the diagonal are all the same. So number 7, we have here if A is a 3 by 3 matrix and the determinant of A is equal to 7, so find the determinant of 5A. We have here 9, 35, letter C 27, letter D negative 21. Okay, so here for this question, since we are given already with the determinant of A, which is 7, and therefore you just multiply that one by 5. Because we are here asked to find for the determinant of 5A. This is just similar to say that the determinant of 5 times 7. So therefore the determinants becomes 35. The answer is letter B. Another question we have here, perform the indicated operation on matrix. So again, we are just asked here to find for the sum of these two matrices, and therefore you just add the corresponding elements. And for letter A, you have that one, letter B, for letter C, and letter D. So let us try to find for the sum of these two matrices. We have negative 5 plus 5, that is equal to 0. We have here 3 plus 9 is equal to 12. And 6 plus 3, that is equal to 9. We have 23 plus 7 is equal to 30. We have 5 plus 3, that is equal to 8. 9 plus negative 8, that becomes 9 minus 8 or 1. We also have 14 plus 2 is equal to 16. And negative 4 plus negative 5 is negative 9. And 0 plus negative 7 is negative 7. Okay, so we have here the sum of these two matrix, which is 0, 12, 9, 30, 8, 1, 16, negative 9, negative 7. And the answer is letter A. Okay, so this one should be positive 12. This is just a typo error. So it should be 12. The answer is letter A. Okay, so that's it for our review for this subject. Thank you so much for listening, and I hope you have learned something, or you have refreshed the ideas for this subject. So God bless everyone and have a great day.